Hi folks, we are back once again with the next video on this maxima minima. We were doing these problems where we were trying to find out the local maxima and minima and the local maximum and minimum value. Those were the work that we were doing. So let's continue with that. We are into the third problem. The second problem we had completed last time. So here it says that there is a function h of x which is sin x plus cos x, where x is between 0 and pi by 2. So let's take this h of x, which they say is sin x plus cos x, and our x value is between 0 and pi by 2. Let me check if it's strict inequality or if there is a, yeah, it's a strict inequality. So x is a value between 0 and pi by 2. It's in the first quadrant. That's what it is. Let's see how to do it. So we have learned that tailor-made format in which we are going to do this. We know that we will take the first derivative and we will take the second derivative. We'll find the critical point and then find out whether it is a point of maxima or minima. So we continue with that journey. So what we are going to do now is we are going to take the first derivative, h dash x, or the first derivative. Sin x derivative is cos x and cos x derivative is minus sin x. That's your first derivative. Let's go for our second derivative, which is the same way. Cos x is minus sin x and sin x is minus cos x. Actually sin x is cos x, but the minus comes back. So that's how it becomes minus cos x. So these are our first derivatives and second derivatives. We go for our next step, wherein we try to find out the critical points. So for that we will say let the first derivative, h dash x, let the first derivative be 0. So that makes cos x minus sin x equal to 0, which makes cos x equal to sin x. And between 0 to pi by 2, the value at which cos x becomes equal to sin x is 45, pi by 4. So the value here is pi by 4, and that's our critical point. So you're getting your critical point from here. Obviously we are going to check next whether your second derivative, with the help of the second derivative, we are going to find out whether it's a point of maxima or whether it's a point of minima. So let's check that. So we have second derivative at pi by 4. Let's check how it is. It should be negative sine pi by 4 minus cos pi by 4, which will be, say, negative 1 over root 2 minus 1 over root 2 minus 2 over root 2, whatever. It's a negative value. Finally we get to know that it's a negative value, whatever be the simplification. This helps us to tell that this point pi by 4, which is a critical point, is a point of, because it is less than 0, it's a point of maxima, and hence they will ask us to find the maximum value. So it's a point of maxima. So we can say that x equal to pi by 4 is a point of maxima. Therefore x equal to pi by 4 is a maxima point, or a point of maxima, and therefore the maximum value, that is h at pi by 4, that's a maximum value, that is going to be sine pi by 4 plus cos pi by 4, which is 1 over root 2 plus 1 over root 2, which is 2 over root 2, and finally root 2. So that is our maximum value. That's how they ask us to do this problem. The next problem is exactly identical to this, except for small changes. So we will try to do that along with this, where we, as I said, very small change. Like you have the next function, it is f of x, which is sin x minus cos x, but x is between 0 and 2 pi. So that's the only change. So you have the fourth question, sub question, which is f of x becoming, once again, let me check, sin x minus cos x. Yeah, it is sin x minus cos x, and x is taking the value between 0 and 2 pi. So as before, we will take the first derivative, we'll take the second derivative, and so on. We'll do that thing there. So let's take the first derivative. First derivative is going to be cos x. For cos x, we know derivative is minus sin x, and therefore this becomes plus sin x, and so on. The second derivative, cos x we know is minus sin x, and sin x we know is minus cos x. So you have it like this, as we did before. Our next step is to get the critical point. And how do we get the critical point? We take the first derivative, we equate it to 0, and that's how we get the critical point, where there could be a hill or a valley in our normal language. So let f dash x be equal to 0. What would happen? That means cos x plus sin x equal to 0, which means that cos x is minus sin x. Now between 0 and 2 pi we have to find out those values. So actually what is the meaning of this? Cos x equal to minus sin x means they are numerically equal, but there is only a difference of a minus sign, like if one would be 2, the other one would be minus 2, something like that. So they if you just look at the number part would be equal for both those ratios, but only that the signs they vary. Okay, now it's very clear to us that there is whether it is 30 degree or whether it is 0 or whether it is 90 or whether it is 60, there is no place where cos and sin becomes equal except for 45. When it is 45, definitely we know that at 45 or multiples of 45 rather, at 45 degree you have cos 45 equal to sin 45 or pi by 4. Similarly at 3 pi by 4, that is there also we have such a thing happening where we have the cos and sin, where they are inverse, because they are in the second quadrant, and that is why such a thing does happen there. So that's going to be our ratio. So let's see now, as I said, that this where do you have this cos x becoming minus sin x? So that's how it is. So as I told you, it has to be a multiple of pi by 4. We have those things happening in see, the only places where this can happen is it cannot happen in the first quadrant, because there that sin x and cos x are 45, sin 45 and cos 45 are equal. It cannot happen in the third quadrant also, because in the third quadrant both sin and cos are negative. If you know that sin ratio and cos ratio, they both are negative there. So therefore you cannot have these becoming, one becoming negative and the other one becoming positive is not possible. So actually it is possible only in these two quadrants, because there the sin and cos, they have opposite signs. So actually here it's like pi minus pi by 4, and here it is 2 pi minus pi by 4. These are the two places where you have sin x becoming equal to minus cos x. So it's by that logic that you are getting x becoming either that it can be pi minus pi by 4 or it can be 2 pi minus pi by 4. In both these places you can have this happening because we know that in this quadrant only sines are positive, cos is not positive, but at the same time here cos is positive, sin is not positive. So like that, one can become the negative of the other and this ratio can become fine. Okay, in these two quadrants, as I said, we have to rule out, because here both are equal and here both are negative. Again, there also they are going to be equal, so you cannot have that possibility. Having these numerically equal is only possible at pi by 4. So it's with all that criteria that you are going to get that x is these two values. Now let's check how this comes. Pi minus pi by 4 for us, you can do all the equalizing etc. and you get to know that this is 3 pi by 4. Here also you can do all the equalizing, 8 pi minus pi by 4, which will come to 7 pi by 4. So these are our critical points. 3 pi by 4 and 7 pi by 4 are our critical points. We have only reached the critical point. Next, it is for us to check whether it is a maxima or a minima point. So in the next thing, we will check f double dash or the second derivative at 3 pi by 4. Let's check what it is. Second derivative at 3 pi by 4 means it's minus sine 3 pi by 4 minus cos 3 pi by 4. Here, minus sine 3 pi by 4, as I told you, you can write it as pi minus pi by 4, and this is also pi minus pi by 4. Second quadrant, it's a quadrant for sine, so sine is going to be positive, so it's going to be just sine pi by 4. The negative will stay as it is, but this is going to be negative cos pi by 4. Why? Because it's not the second quadrant is not the quadrant for cos, so it will take a negative sign. So it's going to be negative cos pi by 4, and already a negative is there. That way it will become positive cos pi by 4. So here it's going to be minus 1 over root 2 plus so therefore it is minus 1 over root 2 plus 1 over 2 Yes. Yeah, I was just wondering. I'll just have a quick check. Cos is minus sine and sine is minus cos. Oh, I made a small error here. This is plus cos. That's why I was wondering, why is this not coming fine? So this is plus, and as a result, because of this minus, it will become minus. Please note this change. I accidentally I wrote sine as minus cos. It's not minus cos, it's plus cos. Anyhow, this is how what happens. And then yes, so therefore this also happens to be negative. That way you get minus 2 over root 2, which comes to negative root 2, which is less than 0. So the 3 pi by 4 is a point of it's a point of maxima, is a maxima point. And the value, so if you want to find the value f at 3 pi by 4, if we have to find, so it's sine 3 pi by 4, we already have the values with us. Sine 3 pi by 4 minus cos 3 pi by 4. Sine 3 pi by 4, you already know it is sine pi by 4, which is 1 over root 2, and minus cos 3 pi by 4, but already it's minus 1 over root 2, so it's going to be plus 1 over root 2. So that's going to be 2 over root 2, which is root 2 as a value. So also we will check whether 7 pi by 4 is a maxima point or a minima point. The second derivative, it is minus sine 2 pi minus pi by 4 plus cos 2 pi minus pi by 4. As we know that last quadrant or the fourth quadrant is a quadrant for cos and not for sine. So sine will become negative, cos will remain positive. So it's going to be, this will become negative. So negative sine, this will become negative sine pi by 4. So that will become positive. So sine pi by 4. And this can become, it's in the last quadrant, so that will become, that will stay positive because it's a quadrant for cos. So it's going to be cos pi by 4. So it's 1 over root 2 plus 1 over root 2, which is 2 over root 2, that's root 2 and it's positive. So this is a point of minima. 7 pi by 4 is a minima point. Okay, then in that case, let's find the minima value, 7 pi by 4. We have the values with us, so it's not going to take much time for us to find out. 7 pi by 4, the sine value, we have got it as 1 over root 2, and the cos value, wait a minute, we are in the, this is the fourth quadrant, so fourth quadrant, alright, so cos value, it's going to be, sine value, it's negative, so let me keep the negative. It is minus 1 over root 2, and the cos, minus cos, so that's again minus 1 over root 2. It's going to be minus 2 over root 2, which is negative root 2 as a value for the function. So this is the maxima value. Here is the maxima value for one, and this is the maxima value for the other one. So we had the maxima, please note that change. There was a small error when we did, and I did make that change, so please note that change. So that's how we get the, we found out the critical points, and we then used it to find out how we can get the maxima and minima value. So that's about it. It's a beautiful problem. It's been asked number of times, and it is taking your trigonometry into check, you know, whether your 11th trigonometry is good or not. That's what it is checking. So that's about it, and that's about this video. We have more problems, and we're meeting in the next video with more problems. Do subscribe the channel and encourage others to share it and spread a word. Thank you.